In our new application, there's a function called die. Though I don't know how to exactly pronounce it. This is this word, yeah. Throwing the die that has the C6. There's the cube that you can throw, and you'll get a number between 1 and 6, and we have to test it. So because we already know that there is a function called CMP we think that, well, it's a number between 1 and 6, so it's okay that we compare it this way. So we throw the die, get the value, and then compare whether that value is greater than 1 and smaller than 6. There are 2 test cases for each throwing the die. We run it 4 times, so it's a total of 8 test cases. And if we run this, everything looks fine. So we take this to the management, and we ship the product, and soon people will start complaining that the die doesn't function properly, that it has all kind of strange behaviors, and some people even mention that they are seeing numbers like 1.5 coming out from the die, even though it's an internal function. So the first thing that we can do here is go back to our test, and here right at the test, in addition to actually comparing the values, we can print out the value using diag, just to see what's going on there. So if we run the script, we see that, well, besides that there's actually a failure now, there's even a test failure now, you can see that the numbers are coming out. Some of them are 1, that's okay, but sometimes it's 1.5 and 5.5. So obviously there is an issue here that the test didn't catch. So we have to improve our test. Actually, it wasn't really a good idea to compare it with the equal sign. It would be much better probably to compare the values using exact comparison of one of the 6 values. So we can use the grep function. We can compare the value if it's equal to one of the values from the list of 1. I'll spell it out because well, I could put in the range 1 to 6, but I wanted to be clearer here that it can be actually any list of numbers. So I'm checking this whether one of the values is whether the value is one of the values from the 6 numbers, and then that's basically the OK function. So this is what we have to put in the OK function, and then instead of 2, now I have only 1 test. So I change here. I don't have to say 2 times 4. It's actually just the 4 test, and then now we can run the test. Obviously, that's much more important to actually fix the application, but we are testers, so we have to make some focus on why the test failed and make proper tests. So now if you run the test, it properly fails where the number is not the right number, so it's 6.5. Now we had this diag, but this diag is not really nice here, because in the end it's printing out even when the number is okay. Now in this case actually none of the numbers were okay, but if I run it again, you'll see that hopefully you'll see that there are numbers that it's just printing like this 4, and this is okay. It's a bit too much information here, and besides we don't really see here what the expected value, and it's not really connected directly to the failure that actually print out. So it would be better to print out this diagnosis information only when the test fails. So that's one thing, and we're going to fix that soon. But there's another minor thing that we are using here grep, which is fine, and that's probably okay for many people. But maybe it's better to use the proper function to check whether any of the values is matching, and for that we can use the module which is called list more utils, which provides many functions. One of them is the any function, and then the code looks exactly the same, but I think it's more expressive that we are checking whether any of the values is matching that given values. So I run the test, and it has the same output, the same failures. Of course, the numbers are different all the time because these are random numbers. So one thing is that we had this any, but the other thing what I mentioned is that the diag is I don't really want this diag here, but luckily all these OK and is and like functions that test_more provides, each one of them returns actually true or false, whether it was true or false. So we can use that and the short circuit nature of Perl, of the OR operator, to write something like this. So whether the OK was successful, and if not, or then print out this output, provide this output. So now we have a diagnostic message, which is going to be printed out only if the test actually fails. So if I run the script now, again, it will print out at not OK, and it will print out the number 6.5. That was the number that was received. Now we can even improve it a little bit just by actually explicitly saying that received, and then printing out even a new line to make it nicer, and that can make the output much nicer. Let's just run it. Okay, so we failed and then it's received. Now our management tells us that we are going to have actually an improved version of this die function. The way it will work is that you can actually get a parameter here. So the default is 6, but if we can provide a number here, that would be also a different size of the die. So you can have 8-sided dies or 7-sided dies. So what if we test both? So now we are going to test this too. Obviously now I have 2 times 4 tests. So again, I have to put here, let's say 8, just to show that there are 8 tests. And in this case, I'll have to put here the correct number of values. And then I can run the test. And I get all kind of reports here, 1.5, 5.5, 2.5, and but it's unclear. I mean, from just look at it, it's unclear which test was belonged to the 6-sided die and which test belonged to the 8-sided die. We can look at actually the line number here. It's 11 and 17, but it's not really the best way, and especially if you have different many of these tests, and you have to rely on the actually right number every time. Instead of that, it's usually much better, as the is function, for example, is doing. It's showing that this is the actual value, this was the the received value, or the actual received value and the expected value. And here we only have the received value. So why not print out also the expected value? And for that, we can type in something like this. We can write here expected number between 1 and 6. We can write it, and then we have to repeat this here. So I'll just copy paste it, and of course I have to update the value here. So we can do that, and it's gonna be better. Let's say it's better because now when it failed, it says looks like what? Sorry, it received 2.5 and expected 1.8. Maybe I should indent it a little bit more, and it will be even nicer. But let's think about it a bit further. What if we are not talking about only dies? We are talking about all kind of other values. So it would be maybe better to actually show the actual values that we were expecting. And for that, maybe it's probably better to create an array separately. So this is the expected list of expected values. It's 1, 2, 3, 4, 5, 6. Okay, and then here we have in this we can already put here the expected values, and here the expected numbers we can put we can join here something. So we say join, we take the values and just combine them. So let's try this code. So we are taking all the expected values, mapping them together, and joining them into one string. And let's see if I made any syntax errors here. No, it's working. So here we can see that the received value is 5.5. The expected numbers are these. It's much clearer for people who see this that what the problem is. Obviously here and now I have to copy paste the whole thing again, which is not really a big problem. Let's I mean, in the end, everything is the same. So these 3 lines are exactly the same now that we have a variable. So if we run this code again, then we'll have, well, apparently this is the 6th version because I forgot to update the expected value now. Of course, if you're using subtest, it would be much nicer here. And still a bug. You see, that's why one shouldn't record live. And here we are. So there are cases when there are 8 are failing, and then here are cases where only the 6 were expected. So this is really all good, and now it's much nicer to see the test reports. But obviously this repetitive code, I mean, almost everything is the same. The only difference here is that how we declare the list of values and the cooling of the die. So either we can put the whole thing into a loop, or what we might want to do is take these 3 lines basically, and put them into a subroutine. And that's what we are going to do in the next video.